buoys are instruments that measure meteorological and oceanographic variables, such as atmospheric pressure, air temperature, wind direction and speed, water temperature, wave height, wave period, and quality of water. Data buoys are sometimes called unmanned ocean monitoring stations. The first data buoy in Taiwan was deployed in 1995, opening a new chapter in observational oceanographic weather research in Taiwan. A total of 16 data buoys have been deployed around Taiwan, forming Taiwan's oceanographic monitoring network. The hardware and the operating system of the network were developed by the Coastal Ocean Monitoring Center, COMC, of National Chung Kung University. It is difficult to imagine that the current COMC headquarters were built on a parking lot in 2000. The successful story of COMC, the research center maintaining all key technologies of Taiwan's ocean buoys, began 20 years ago. In a meeting held by the Central Weather Bureau, CWB, on January 11, 1993, Director Ching Yen-sai decided to form a committee of maritime specialists to establish a wave monitoring network around Taiwan within 5 years of time. In a symposium on ocean analysis and forecasting, 4 local and international specialists proposed that Taiwan should set up an oceanographic monitoring network. Accordingly, the CWB began to sketch the blueprint of Taiwan's ocean-based weather monitoring network. The proposed network consisted of oceanographic data buoys, following the standard of the National Data Buoy Center, NDBC, of the United States. A timetable and guidelines for implementation were also proposed. The implementation started with deploying buoys along the coast, not only to gain experience, but also to familiarize fishermen with the new objects. As the technology matured, deep-sea buoys were also put into operation. The 2 pioneers in setting up the data buoy network were Director Bien-Jun Lee of the Marine Meteorology Center at CWB and Professor Jia-Jun Gao of the Department of Hydraulics and Ocean Engineering at NCKU. The first oceanographic data buoy was deployed outside the Taichung Harbor on October 28, 1995. This system was designed and manufactured in Taiwan. It could collect, analyze, store, and transmit on-site data from the station. The success of the project owed a great deal to the persistence of the 2 pioneers. One practical challenge for the project team was the new government procurement rules that came into effect on May 27, 1995. According to these, Professor Gao, the project leader, was considered a manufacturer selling instruments to the government. This disruption had greatly reduced the flexibility on which their research depended. 20 years ago, Taiwan did not have the necessary technology for producing its own data buoys. Thus, the government had to purchase instruments from abroad. Since most foreign companies refused to reveal commercial secrets, Taiwan had little control over the monitoring process and could not freely decode the obtained data. Professor Gao has broken down the national development on oceanographic monitoring technologies into 3 stages. In the first stage in 1989, Professor Gao developed a system to capture, decode, and analyze wave data, and also developed several analytical procedures. He overcame the black box effect of using imported components and opened new perspectives in Taiwan's oceanographic monitoring technology. In the second stage in 1990, Professor Gao installed an ultrasonic water level sensor on Taiwan Power Company's pier at Qingda Harbor. The sensor successfully detected waves and transmitted data to NCKU via radio signals. In the third stage, with support from the National Science Council, 3 pile stations were designed and deployed on the sloping shore just outside Taichung Harbor. The goal was to investigate wave shoaling. Later, Professor Gao set up another pile station at the Taishi coast. In 1996, a wave monitoring system was installed on the oil rig in the northern Taiwan Strait under the support of CWB. This system investigated how monsoons affect weather conditions over the Taiwan Strait. In 1994, at the request of Director Bien-Jun Lee of CWB, Professor Gao began to design Taiwan's first data buoy system. To ensure a smooth operation, Professor Gao and his team standardized the calibration of the monitoring instruments, including various tests for measuring the azimuth, acceleration, and frequency of the motion of an individual buoy. Despite the skeptics, the first-generation buoys were manufactured and deployed by Professor Gao's team in 1995. The successful on-site acquisition of the data demonstrated the feasibility of Taiwan's emerging oceanographic monitoring systems. However, the iron hulls of the first-generation buoys were also responsible for confusing data read by the built-in compass. To solve this problem, the hulls of the second-generation buoys were made from aluminum alloy. Both the first and the second-generation buoys were moored by chains in shallow water. Thus, a carrying vessel had been designed to deploy them. A fishery boat was usually hired for transporting the buoy and the vessel to the deployment location. In order to extend the transmission distance for remote locations, maritime satellite transmission function was added to the second-generation buoys. This was important for such buoys located near Taiping Island in the South China Sea. The second-generation buoys suffered from two problems. Passing ships could damage the wind meter, and maintenance in rough sea was difficult. The third-generation buoys overcame these problems by adding fences around the buoy to protect the onboard instruments, as well as to increase the safety of the staff working on site. The opening of the buoy compartment was also redesigned for easy access and efficient maintenance. As the technology matured, Professor Gao and the team began to develop deep-water buoys along with the related monitoring systems. In 2005, a fourth-generation buoy was released, based on the existing structure with enhanced buoyancy. In May 2006, Professor Gao and his team deployed the first deep-water buoy at a depth of 4,800 meters at a spot 200 kilometers away from Taiwan's eastern coast. This CWB project unfortunately failed. However, it motivated the team to try again 3 months later. The second time, the deployment was successful. This deepest anchored buoy in Asia greatly extended the CWB's ability in forecasting typhoons. In anticipation of Typhoon Shanshan in 2006, COMC's distant water buoy demonstrated its accuracy in weather forecasting. The CWB predicted the diameter of the storm to be 200 kilometers, while Japan's meteorological agency predicted it to be 300 kilometers. The CWB's prediction was later proven to be much closer to the correct value. Professor Gao began his work in oceanographic monitoring after returning to Taiwan with his PhD degree in 1983 from the University of Hanover, Germany. Professor Gao had foreseen that the lack of on-site data would limit the development of Taiwan's maritime engineering. Therefore, Professor Gao dedicated himself to oceanographic monitoring, despite the unpredictable and risky nature of the work. Professor Gao's persistence has led to more than 10 patents, the establishment of an SOP for calibrating data buoys, and the comprehensive acquisition of oceanographic data around Taiwan for the government. Since 1994, the COMC has been extending the National Oceanographic Monitoring Network of Taiwan. The data acquisition rate has reached 95%. Nothing is more dangerous than quoting erroneous data. To provide high-quality data, the COMC developed a quality control program for meteo-oceanographic data based on the QC standard of NDBC of the U.S. The quality control efforts of the COMC paid off. During Typhoon Krosa in 2007, the data buoy near Turtle Island off Ilan measured the highest wave at 23.67 meters. Typhoon Jelawat in 2012, the deepwater buoy off the coast of Taidong measured the highest significant wave at 18.88 meters, and the waves reached 11 meters for 13 hours during that storm. The measurements and maximum wave heights in these two cases were validated by the Quality Control Program. In 2013, Professor Gao received the Award of Engineering from the Chinese Institute of Engineering for his outstanding achievement in oceanographic observation research. Professor Gao is the only recipient of this award as an in-service professor. Furthermore, Professor Gao was awarded the Da Yu Prize in 2014 by the Ministry of Economic Affairs for his excellent contributions to hydraulic engineering research in Taiwan. As Professor Gao approaches the end of his remarkable professional service, we wish him well and hope that he appends another chapter in oceanographic studies after his retirement in 2015.